Hello again, all my distance learners out there. We're getting ready for our fourth day, excuse me. We already had our third day. Fourth day of notes, and today we're going to be talking about patterns with powers of 10 with negative exponents, and then changing powers of 10 into decimal numbers or standard notation. So, just a reminder from yesterday when we were dealing with powers. This whole number we're dealing with here, this whole thing, pencil, this whole thing here is called it's in power notation. And then, if we remember from yesterday, 10 here is what we call our base, and the little 2 hanging up above it is the exponent. Alright, so we're going to take a look for some patterns here when our exponent, the number up above the 10, is positive. So, 10 to the 0, its meaning is kind of hard to understand right now, so we'll just kind of leave that blank. We're not really worried about what 10 to the 0 is, but we want to know what it is. So when we take any number to the 0 power, that thing is just going to be 1. I could take 1,000,000 to the 0 power, and it will just be equal to 1. So any number to the 0 power is 1. So here's where we're going to start filling in our meanings here. So 10 to the first power, if we remember from yesterday, if we have any base up to the first power, that means we just have one grouping of that thing. And so 10 by itself here is just going to be 10. And then we have our example here, 10 squared. If we remember from yesterday, we take our base of 10, and the squared, or the 2, exponent of 2, tells us to multiply that together twice. We have 2 groups of 10 that we're multiplying together. So continuing on here, 10 to the third, we're just going to follow that pattern. We are multiplying 10 together 3 times. And 10 times 10 is 100. 100 times 10 gives us 1,000 for the standard form here. So this pattern is going to continue. We have 10 times 10 times 10 times 10. For 10 to the fourth, we've got 4 factors of 10. And this is going to be 10,000. And I'm sure we can see what's going on from here. 10 times 10 times 10 times 10 times 10 for 10 to the fifth, and that is 100,000. And finally here, 10 to the sixth, we've got 6 factors of 10, so we're going, there's 1, 2, 3, 4, 5, and 6. And that is going to give us, in standard form, 1,000,000. So give this a think. If this pattern were to continue, how many factors of 10 would we have for 10 to the 13th? And our standard form number would be a 1 with how many zeros? See if you can find a pattern happening here from our increasing powers of 10. So I want you, by yourself, to list some of the patterns you see here. Don't just copy me here and write a line. You're actually writing a sentence or two of the pattern you see. Alright, we're going to take a look at what happens now if our exponent is negative. So we can kind of see from above that we were just taking our decimal and moving it. So 10 to the 0 was 1. 10 to the first was, well, we have a 1, and we move that decimal over once and gives us 10. And if we had 10 squared, we would move that decimal over again, and that becomes 100. So the negative exponents are going to work kind of the same way. We would start with our 1, and then since it's a negative 1 here, we're going to move our decimal back this way 1. So just to write this without that little whoop-de-doo there, we're going to get 0.1. So negative 2 means we have our 1, and then we move our decimal to the left, once and twice. there. So that will be 0.01. That pattern is going to continue the same way all the way through it. So 10 to the negative 3 would be 0.001. 10 to the negative 4, 0.0001. And I think you can kind of see the pattern that's going to happen here. And 10 to the negative 6, 0.000001. 10 to the negative 13th, holy moly, here we go, same kind of pattern though. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1. That would be 10 to the negative 13th. So that was kind of a pain in the butt to write, and we can see how our power notation here would be much easier to write out if we were doing calculations with this thing and had to write it over and over again. So once again, I want you to write a sentence or two. Don't just copy my line, but actually write yourself a sentence of the pattern that you see happening. I've kind of already explained the pattern, but I want you to kind of give it a think and write it in your own words there. Alright, so now we're going to take a look at how we change a power of 10 with a positive exponent into a standard number. So, our example here is 10 to the 4th. So this is kind of mentioning that pattern I wanted you to write about above. So since it has a positive exponent, we know that this number will be a whole number, no decimal parts. So we're going to take a look at the exponent, and it's going to tell us how many zeros we put. I kind of feel like behind is to the left, so we're going to change that to after the 1. So since we have an exponent of 4 here, we're always going to have our 1 be the first number there. And since our exponent is 4, we're going to have 4 zeros. So 10 to the 4th is 10,000. So it tells us to add our commas. We don't have to, but if we wanted to, just go to your, after your hundredths place, or excuse me, thousandth place, and put your comma there. But I will accept answers with no commas. So since this is a pretty easy process, we'll just do the first couple here, and I want you to try the others on your own. So 10 to the 8th, if we're following our example above, our 1 is going to come first. We're going to have 1, 2, 3, 4, 5, 6, 7, and 8 zeros. And once again, if you wanted to, you could comma this out. We have 100 million. Now going the other way, we want to change this into an exponential form, as we have up above. So our base, when we multiplied 10 together, and how can we tell how many 10s we multiplied together? Well, we just count our zeros here. So we have 1, 2, 3, 4, 5, 6, and 7. So our exponent, to turn it into exponential form, would be a 7. 10 to the 7th is what this thing here is equal to. So I want you to try to change the other two into standard and exponential form yourself. Alright, so now changing a power of 10 into a negative with a negative exponent into a standard number. This will be a decimal form since our exponent is negative. So since it has a negative exponent, we know it will be a decimal, just like I said before, and it will not have a whole number part. So we don't have to write this, but it will be 0 point something, no whole number whatsoever. So we're going to take a look at our exponent. So this is going to tell us how many places now behind works the decimal, or how many are, well, I guess this doesn't work again. How many places are ahead of the decimal, or we'll say after. So after the decimal, we're going to put in zeros and a 1 so that we have the correct number of places. So up here for 10 to the negative 4th, our decimal places would be 1, 2, 3, and 4 altogether, so that last one will be our 1. 10 to the negative 4th is 0.0001. So the 1 will always be on the last place, and that will be the place of the exponent that we have. So doing that again, start with our decimal point, and we know we're going to have 6 places after this. So, and that includes the 1. So we will have 1, 2, 3, 4, 5 zeros and a 1. So I'm going to have you try that second one all by yourself here soon. But now we're going to change this number here into exponential form. So we know we're going to have a 10, and we want to count how many decimal places are after that decimal. So we'll just start counting them up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this will be 10 to the negative 11th. Then I'm going to have you try this next one all by yourself as well. So that is it for the notes today. The rest after this will be your independent practice. So you will see all of this stuff, or I guess this second page, with the negative exponents on there as well. So don't worry about the top, because we did that in our notes right now. And you're just going to take care of independent practice. So you are going to try to fill out this chart. Try to do it without using the notes that we just took. And then we've got a few problems writing these lists of numbers in both ascending and descending order. So remember, descending means our numbers are going down, so from highest down to lowest. And ascending is the opposite. We are raising our numbers, so our numbers will be smallest to biggest. All right, so go ahead and complete this assignment. Whoops. And you can snap a picture of that and turn it into the turn-in bin.